So let me check the audio and video all. Is everything working fine or not? I think my audio is not working. Is it working right now? Hello, hello. Okay, so it is working. Hello. I is it working right now? Okay. Hello, hello. Okay, so it is working. Hello. So let me start. Okay, so what I'll be doing here is I'll be discussing about this the IoT thing that I had built, and let me show you the previous videos about this thing. Wait, it would be better if I'll let me show you the full story. So this is my YouTube channel. Uh, what I had built earlier was this thing. So this is the device that you are able to see. This is an IoT device, and this will be connected to the Wi-Fi, and this will be controlling this pump controller, pump starter. So there is one wire that is connected to this thing here, this wire. So this is going to the sensor, ultrasonic sensor. I had shown that in this short video. Let me skip it. Maybe I opened the wrong video.
एक प्रॉब्लम मैंने बहुत कॉमन देखा है.
Let me show that. Move it to the that point directly. Oh, wait. So this one.
ये
So here you can see the sensor also.
सेंटर में आपको दिख रहा है.
Here is that sensor facing down towards the water, and this is how it is connected. A wire coming out from the overflow space for overflow.
स्टार्टर.
So this is the setup, and here is the wire, the same wire, that black wire is converted into this Ethernet cable, and this thing is connected to this device. This is supposed to turn this thing on and off, but right now this is very old model. When I had built it for the very first time. Currently what I am building is for this thing. This is for submersible. It will turn it on and off automatically, and after connecting to Wi-Fi, let me show what it will be doing. So this is that pump controller, that hardware thing that you saw. So that is connected to Wi-Fi, and using MQTT it will be sending message, publishing its current state. I mean, by current state, I mean how much water is in the tank, and what is the state of the pump. Is the pump running right now or not? What is the current voltage, current draw, and every other matrix, it will be that will be published through MQTT. So I'll come on this topic later, that why I chose MQTT and what this thing was using earlier. The video I saw you was the device from 2 years ago. So that thing is using actually HTTP instead of MQTT, that is long polling. I'll talk about that later, but let me describe the whole flow first. So the MQTT publishes all the information, all the states, telemetry and all about this device to the MQTT broker, and this broker is then connected to node server. So node server is actually subscribed to one of the topics that this controller is publishing to. So if message is published via this device to the broker server, so then the node server will know this. Then what will happen? I'll store it on the database. Most of the time, no. I'll store it directly on Redis. Let me write it down. Oh, wait. This is Redis. So since this data is being published very rapidly, like once every 5 to 10 seconds, so writing this thing down directly on the database is waste of resources. Since this thing, for if I wanted to make a college project or something, this one, a database can easily handle that much of write, because one device will be there. But as soon as this thing will get scaled up, it will make no sense to store it in that database, because we don't need that data for very long. We need to process that data and store the processed thing. I'll be running the cron job also, one for hourly aggregate of the data that is being published here in the Redis. So currently whatever the water level is, that will be stored in this Redis server, and every 1 hour there will be one cron job running that will read the average of whole hour and store that as an hourly average. Similarly, the hourly averages will be averaged out as a daily average, averaged out for the whole day, and that will become daily average. So this will happen. This is the auth flow. I'm using Google OAuth, but later I have realized that I'll have to implement some custom auth also. I mean, custom auth means email auth, email and password. Alongside this auth, I have used JWT, so this won't be that much of an issue. This is already ready to be adopted for that case, email ID and password. So I haven't included any screenshots here for the app. Okay, I'll include that, or I'll show you that. I have actually published that on YouTube. So this is the basic setup of how things are working here. There are many things that I need to improve. For example, there are some JSONs being stored in Redis which I don't want to be stored here. I want them to be as an hash map. That will improve the performance significantly. So so I'll be talking about now why I chose MQTT and it uh, how it is different from how it is improving the performance as compared to long polling, or why I've used WebSocket. I've used WebSocket for mobile app. Here there is two way of connecting. There is one more way. Wait, let me make space for this. So there is one more way it can be connected. It can be connected either via HTTP, or there is one more way. Of WebSocket. Wait, let me delete this thing. I'll need a bidirectional arrow. Do you guys have any idea how to implement bidirectional arrows here? Arrowhead. Okay. This one. Okay. I'll draw it. Okay. So one more arrow. This is bidirectional. Why I have shown bidirectional here? Because both of these are MQTT. Sorry, WebSocket. Here user means the app, the client side app, the mobile app. WebSocket. I can turn this thing also. Hmm. Okay, so this is WebSocket, and I've used WebSocket to send live data to this user, and so that WebSocket WebSocket can also help it connect back, send back live instructions to this device. For example, if I wanted to send a command to turn on the motor, turn off the motor, I can use it. I can send that through WebSocket, and that will send a command to MQTT broker, and this is subscribed to a topic, so this will also receive. All these things are going to happen in real time. But there is one more way with which I can improve the performance and reduce the load. that is through Matter. Matter is actually a protocol that can be used so that this thing, the mobile application, can locally connect to this device if they both of them are on the same Wi-Fi without having to go through all these services. If I want to turn the motor on, the pump on, it will go direct, the message will directly go to this thing. So the user interaction and everything, this load will get reduced, and I can reduce the telemetry frequency, which is currently 1 minute or 5 minute, every 5 minute or every 1 minute. I can reduce that to a little bit more to reduce the load on this server. So Matter I'll be implementing later. HTTP long polling, which I was using earlier. So HTTP long polling was the worst way to implement this. MQTT and WebSocket is the practical way to implement this, and Matter is, I think, till now, as much as I know, this is the best way, but there might be something else which might be better suited. But for now, MQTT and WebSocket is also good enough to work at a scale with this architecture. Since the user won't be online every time, the device will be online 24/7. So I need to optimize this pipeline much more than this one. This one is only happening when the user is opening the app. So even if this is not that much optimized, this is not a big deal for me. But if this pipeline is not very well optimized, it will be a huge headache for me. It will be an expensive thing to do. So MQTT is actually much lighter than WebSocket. I could actually, initially I didn't had much idea about MQTT, so I had thought about implementing it through WebSocket, but later I found that this won't put much effort, use much resource of my IoT device also, that is an ESP32. So it won't put much load on ESP32 also, nor on my server, nor on my MQTT broker, nor on my server. So this thing reduces a significant amount of load here. So I used MQTT, but Matter might reduce it a little bit more. Using WebSocket actually uses about 2 kilobytes of RAM on my server per user, but this thing is far more efficient. This thing uses a few bytes depending on how big of the data I am sending to the service. It will depend on that, but it can be in bytes, single digit bytes. So it is much more efficient as compared to 2 kilobytes. It can be 2 bytes. So not 2 bytes, that is too low, I think, for what I'm the amount of data I am sending. So it is very, very efficient as compared to WebSocket. So it is scalable, and this is what I wanted to show you. There is one more thing, that few more things that I might be able to show you. The app, you can see my YouTube channel also. There is video about that app. Let me show you directly. Oops. Wait. Is my audio working? Yes, I think it is working. Hopefully it has not created any issues. I couldn't find that. Still, let me see. That might be in sorts. this one. So this is the app. You can see this video, and this is how the UI looks. So this was all that I wanted to say here. I have also updated the design, and the updated design, let me show you the current one that we are developing. Let me open that. So these are two prototypes that I'll be testing and changing a few things. After that, I have plans of implementing it in a few homes so that I'll know how durable this thing will be. So this thing, that black dot that you are seeing, is actually a 5D rocker joystick. So you only need to push it up, down, right, left, right to navigate the menu, but you might not need to. And there will be two more buttons, one red button, one green button, as usual, for turning the pump on and off. So this was all that I wanted to say. So bye. I'm ending this stream right now. See you again in another video, or maybe in Instagram or YouTube, both. I'll be live on Instagram and YouTube both very soon with the new information of how I have upgraded all these things and about the version